Good morning, students. Welcome back to our physics classes. During the last class, we have derived equations of motion and we have used the method of graph to derive that equations of motion. We have derived four equations of motion, and these four equations of motion we derived based on a simple single graph, that is a velocity time graph for a uniformly accelerated motion. I already told you the same equations of motion we have to derive using another method also, and that method is the method of calculus. Calculus method, using the method of calculus, we have to derive all these four equations. So it's a new topic to you. Calculus is a new method to you. So before deriving equations of motion using calculus, we have to go through the basic idea of this method calculus. I just told you, mathematics students, you are going to learn this calculus in your mathematics classes, but bio students, you are not getting the chance of learning more about the calculus. But the basic idea and the general rules that we are using in physics classes, that we are going to discuss here. That means whatever we require for our physics classes, that we have to derive or discuss here. Okay, so listen very carefully. This is a new method for you. So first you will think this is an abstract idea, but when you are practicing this, it will be more easy for you. So in the first sense or the first sight, it will be more tough. I mean, little bit tough for you. You will feel little bit tough for you, but actually it is not too tough. It is very simple, and you listen carefully and practice yourself. Then it will be more easy. There is no direct questions will ask for your exams directly from calculus, but calculus is used for deriving some physical aspects. So that is the importance of calculus in physics. As I already told you, calculus is invented by Isaac Newton, and now this calculus is a part of mathematics. You know, Isaac Newton was a mathematician initially, and he found more beauty in physics. Then he changed his focus, attention from mathematics to physics. So he has used many mathematics steps and mathematic tools for deriving physical steps. Okay, so anyhow, we have to go through calculus. So we have to start with calculus. Calculus is a mathematical method. Calculus is a mathematical method. There are two kinds of calculus. There are two types of calculus method. One is differential calculus and the other is integral calculus. One is differential calculus and the other is integral calculus. Both the methods are new for you. So what do you mean by differentiation, or what do you mean by integration, or how you can take the derivative of a function, how you can take the integral of a function, how you can differentiate a function, how you can integrate a function. So all these matters we are going to discuss now. Okay, so let us start with differentiation. Let us start with differential calculus. Differential calculus is also known as differentiation. Differential calculus is also known as differentiation. Okay. Okay, you know what is a function? Already you have learned from your maths class what is a function. How you can define a function? A function carries two variables. A function carries two variables, an independent variable and a dependent variable. An independent variable and a dependent variable. So, dependent variable you can call as a function. Dependent variable you can call or you can express as a function. And its value is determined by its independent variable. So, the function's value depends upon that independent variable. As the independent variable changes, the value of function also changes. Simple example you can take. You already came across or you already learned about polynomials. P of x. P of x is equal to, suppose ax square plus bx plus c. You are having a polynomial p of x is equal to ax square plus bx plus c. P of x is a polynomial and whose value, which is a function of x. That is why we are calling that p of x. It's already you have learned, is it? So p of x is equal to ax square plus bx plus c. A, b, c are three constants, and p of x varies or p of x is determined by that variable x. Is it? If you put the values of x different, then you will get the value of p of x as different. Corresponding values you are getting. Is it? So we can say that x that you are deciding, that is why it is called independent variable. It is not depending upon any other function. It is an independent variable. And as here in that polynomial, x is the independent variable. So as you change the value of x, then what will happen? Depending upon the value of x, the value of p of x is changing. Is it? Similarly, we are defining a function f of x. What it means? F is a function of x, which means as the value or as the variable x changes, it changes the value of f of x also. Is it? Suppose you are having a function f of y. What it means? F is a function of y. As the value of y changes, the value of f of y also changes. You are having a function of f of t. F of t, what it means? F is a function of t. F is a function of t means as the t changes, f of t also changes. So all these examples x, y, z mean x, y, t, all these three you can take it as independent variable, and f of x, f of y, f of t, all these you can take it as dependent variable, since the value of f of t, f of x, f of y depends upon the values of t, x, y respectively. Which means when you are having a independent variable and its depending function, then when you change the value of independent variable, that changes the value of that dependent variable also. That is the nature of a function. So we can say that f of x, if you define f of x, value of f of x depends upon x. Value of f of x depends upon x. As the value of x changes, suppose initial value you have take x equal to x, then you can have the value f of x, and you are changing that x by delta x. You are increasing x by delta x. So the new value of x should be x plus delta x. Is it? You are increasing delta x means the value of x will now x plus delta x. So what about f of x now? That will be f of x plus delta x. Is it? So as the value of x changes, f of x also changes. That is the nature of a function. A function changes according to its independent variable. A function changes according to the changes in its independent variable. F of x changes according to the changes in its independent variable x. F of y changes in accordance with the changes in its independent variable y. F of t changes in accordance with the changes in its own independent variable t, like that. So differentiation is the method in which we are measuring the variation in a function with respect to changes in its own independent variable. We are measuring the changes happening to a function in accordance with the changes in its own independent variable. So we have already seen, if x changes from x to x plus delta x, f of x changes from f of x to f of x plus delta x. So what is the changes in independent variable? That is x plus delta x minus x, that is final value of x minus initial value of x. So x plus delta x minus x will be delta x. So delta x is the change in x. What is the change in f of x? F of x plus delta x is the final value minus f of x is its initial value. So change in function will be f x plus delta x minus f of x. Simply we can say that delta f is the change in the function. Delta f is the change in function. Instead of f of x, you are expressing that as y. Y is equal to f of x. Y is equal to f of x. Simply it means the value of y varies according to x. So as x changes from x to x plus delta x, y varies from y to delta y. Instead of f of x, we are using y now. So as x is the independent variable and y is dependent variable, as x changes its value from x plus delta x, x varies its value from x to x plus delta x, y varies from y to y plus delta y. Y varies from y to y plus delta y. Okay, so change in x, independent variable will be delta x. Change in dependent variable will be delta y. Delta y by delta x, that is change in dependent variable with respect to the change in independent variable. Are you getting me? I will show you now. Okay, so we have differentiation as y is equal to f of x. We have y is equal to f of x. If x changes by delta x, y changes by delta y. If x changes by delta x, y changes by delta y. Then delta y by delta x, as delta x tending to 0. Tending to 0 means delta x is almost equal to 0. Delta x almost equal to 0 means the change in independent variable is very less. Change in independent variable is very less. So if the independent variable changes very slightly, then how that dependent variable changes. In other words, delta y by delta x, as delta x tending to 0, That is a mathematical expression, delta y by delta x as delta x tending to 0, which means changes in y with respect to an infinitesimally small change in x. Infinitesimally small means very negligible change. Okay, so we are measuring the variation of dependent variable y with respect to an infinitesimally small change in its own independent variable x. That is the method of differentiation, measuring the variation in an dependent variable with respect to an infinitesimally small change in its own independent variable. Measuring the variation in a dependent variable with respect to an infinitesimally small change in its own independent variable. So we are expressing that as we are limiting the changes in x. What is the limitation there? Delta x should be very small. That means delta x should tend to 0. So as delta x tend to 0, delta y by delta x you can express as dy by dx. So you are limiting delta x to a very small value. That is expressed as limit LT. LT is limit. Limit delta x tending to 0. Delta y by delta x is equal, expressed as dy by dx. Expressed as dy by dx. Here y is the dependent variable and x is the independent variable. So in differentiation we are just using the notation dy by dx. What it means, you are taking or you are measuring the changes in the dependent variable y with respect to the changes in its independent variable x. Remember, y is the function and x is the variable. In simple words, we can say y is the function and x is the variable, which means as the value of x changes, y also changes. Dy by dx means the changes in y with respect to an infinitesimally small change in x. Change in y with respect to an infinitesimally small change in x. That is expressed as dy by dx. Okay, so dy by dx, which means you are taking the derivative of y with respect to x. You are taking derivative of y with respect to x. Or mathematically it is that operation is termed as taking derivative of y with respect to x, which means differentiating y with respect to x. So y is a function and x is its variable. So you can take that you can differentiate any function with respect to its own independent variable. You can differentiate any function with respect to its independent variable. Differentiate means you have to measure or you are measuring the changes in that function with respect to its independent variable. So differential or differentiation is an operation. Differentiation is an operation. Just like summation, subtraction, division, multiplication, just like that, differentiation is also an operation. Differentiation also an operation. How you can express that differentiation? That is expressed as d by dx. D by dx means take or differentiate with respect to x. D by dx means differentiate with respect to x. Suppose the variable is t. So how you can express the differential? That is d by dt. D by dt, d by dx, d by dy, d by dz, just like. That is a differential operator. That is a differential operator. For what you can take the differential? You can take the differential of a function. You can take the differential of a function. F of x may be a function, g of x may be a function, f of y may be a function, f of t may be a function, g of y may be a function, g of t may be a function. So for all those functions you can take the derivative. But remember, you can take the derivative of a function with respect to its own independent variable. If you are f of x, you can differentiate with respect to x only. So the operator should be d by dx. If you are having a function g of y, you can differentiate g of y with respect to y, because g of y is a function of y. If y changes, then only g of y can change. Since g of y is a function of y, as x changes, what will happen to g of y? As x changes, what will happen to g of y? As x changes, nothing will happen to g of y, because g of y is not depending upon the value of x. Okay, so you can't take the derivative of g of y with respect to x. So the operator d by dx can't operate on g of y. Are you getting me? D by dx can operate only on functions of x. D by dy can operate only on the functions of y. D by dt can operate only on the functions of t. Okay, d by dx can operate on f of x, g of x, p of x, any values. F of t can, d by dt can operate on f of t, g of t, p of t, whatever may be. D by dy can operate on f of y, g of y, p of y, like that. So an operator is depending upon an independent variable, x, y, z, x, y, z, t, like that. That operator d by dt, d by dy, d by dx, d by dt, like that operators can operate only on the functions which depends upon that particular independent variable. Are you okay? D by dx can operate only on g of x or f of x. It can't operate on f of y or f of t, because differentiation means measuring the variation in a function with respect to its own independent variable. Suppose f of x is a function of x and you are trying to differentiate with respect to another independent variable, it will not be its own independent variable, so it cannot be operated. So d by dx, d by dy, d by dt, all are differential operators, and these operators are operating on some functions, its own functions. Then it can be differentiated. So how you can differentiate a function? When we are going for an example, that will be more easy. Before going to an example, how to make an operator or how to make a differential operation, let us familiar with some general rules in, let us differentiate, let us familiar with some general rules in differentiation. Okay, so we can go for general rules in differentiation. We can see some general rules in differentiation. First one is d by dx of x to the power n. So it is clear that x to the power n is a function of x, and you are taking the derivative of x to the power n with respect to x. So d by dx is the differential operator in x, and it is operating on a function x to the power n. So d by dx of x to the power n is equal to n into x to the power n minus 1. Okay, it's a general rule. d by dx of x to the power n is equal to n into x to the power n minus 1. Second one, d by dx of k, where k is a constant. What is constant? Constant is a variable having definite value, or cannot be considered as a variable, an entity which having a definite value which will not change with respect to anything, that is known as a constant. So if you are differentiating constant means you are changing the, you are measuring the changes in that constant with respect to an independent variable. Since it is a constant, is there any variation for that constant? No. So that cannot be differentiated. A constant cannot be differentiated. So d by dx of k equal to 0. d by dx of k equal to 0. Then d by dx of log x. See, that is log ex. Log ex means there are two kinds of logarithm. Base 10 and base e. Natural logarithm and common logarithm. Base e is known as natural logarithm. So d by dx of log x is equal to 1 by x. d by dx of log x is equal to 1 by x. Okay, so we have two functions, f of x and g of x. Both are functions of x. And you have the sum of these two, f of x plus g of x. And you have to differentiate the sum. That is d by dx of f of x plus g of x. d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. That is, differential of a sum is equal to sum of differentials. Okay. Instead of plus, if you are having minus, you can make use minus. No problem. d by dx of f of x minus g of x is equal to d by dx of f of x minus d by dx of g of x. Okay. Then fifth one is d by dx of f of x into g of x. Product. It's a product rule. It's an important rule. So product rule of differentiation says that f of x you can consider as the first function, g of x you can consider as the second function. So you have the product of two functions, f of x into g of x. And you have d by dx of f of x into g of x. So d by dx of f of x into g of x is equal to first function into derivative of second plus second function into derivative of first. See, f of x into d by dx of g of x plus g of x into d by dx of f of x. Derivative of a product is first function into derivative of second plus second function into derivative of first. Okay, then sixth one is d by dx of sin x, trigonometric functions. d by dx of sin x is cos x. d by dx of cos x is minus sin x. d by dx of k into f of x, a function multiplied by a constant, d by dx of k into f of x. That you can take k into d by dx of f of x. That give me k into d by dx of f of x. These all are the major general or the important general rules that we are using in our physics requirements. Means for physics derivations and physics classes, we are making use this kind of rules. Okay, so these are the basic rules in differentiation. So first function is first rule is d by dx of x to the power n is equal to n into x to the power n minus 1. d by dx of k is equal to 0. d by dx of log x is equal to 1 by x. d by dx of f of x plus or minus g of x is equal to d by dx of f of x plus or minus d by dx of g of x. d by dx of f of x into g of x is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. d by dx of sin x is cos x. d by dx of cos x is minus sin x. d by dx of k into f of x is equal to k into d by dx of f of x. Okay. Okay, these are the general rules in differentiation. I think you are, I know you are getting confused now. So don't think it's an abstract idea. Okay, so the general rules, these general rules you have to learn anyhow. These general rules always you have to remember, and you are making use the general rules for differentiating the functions. So now we are going to some examples, going for some examples, and while solving the examples, it will be easy for you. Okay. So now we are going to solve some examples. I will explain some examples to you, but always remember you have to make use these general rules for solving those examples. So these examples are very, general rules are very important. You keep all these in your mind while we are solving that example. So we can go for examples. See, first function y is equal to 2x square into cos x. First function y is equal to 2x square into cos x. Okay, so you are having two functions. Y is expressed as a product of 2x square into cos x. So you have to differentiate y. Which operator you have to use there? Since y is a function of x, the operator should be d by dx. Are you getting me? Since y is a function of x, to differentiate y, we have to make use an operator. Which operator you have to use? That is d by dx. So you can express d by dx of y, that is differential of y with respect to x. So I already told you d by dx is an operator that can operate on the function. So that will be d by dx into 2x square into cos x. 2x square into cos x. See, it is in the form 8th general rule, that is d by dx of k into f of x. What is k? A constant that can be taken out. So that 2 is a constant that can be taken out. So 2 into d by dx of x square cos x. 2 into d by dx of x square cos x. Okay. Then d by dx of x square cos x. What is that? X square multiplied by cos x. Two functions. And you are taking the derivative of product of two functions. Which one you have to use? Fifth one you have to use. That is d by dx of f of x into g of x is equal to f of x into d by dx of g of x plus g of x into d by dx of f of x. Okay. So that 2 you can keep as such 2 into, then you have to apply product rule in the differential. So first function x square you can keep it as a first function. So first function x square into differential of second, which is second one, d by dx of cos x, plus second function into what is cos x, differential of first, d by dx of x square. Okay, then 2 into x square into d by dx of cos x. D by dx of cos x is minus sin x. See, d by dx of cos x you are replaced by minus sin x, plus cos x into d by dx of x square. D by dx of x square in the form d by dx of x to the power n, which is n into x to the power n minus 1, which will become 2 into x to the power 2 minus 1. 2 minus 1 will become 1. So that will become 2x. So dy by dx will become, if you take the 2 into the bracket, minus 2x square sin x plus 4x into cos x. Are you getting me? Did you get the method? You are having a function, you have to differentiate that with respect to its own independent variable. While taking the derivative, you are making use the general rules. Go for the second one. Y is equal to x cube plus log x. Y is equal to x cube plus log x. Again, y is a function of x. So which operator you have to use? The d by dx. So dy by dx is equal to d by dx of what is y? X cube plus log x. which is equal to d by dx. So which rule you have to use there? That is differential of a sum. Differential of a sum is sum of differentials. So d by dx of f of x plus g of x is equal to d by dx of f of x plus d by dx of g of x. So that is d by dx of x cube plus d by dx of log x. Again, d by dx of x cube will be in the form d by dx of x to the power n. Which one you have to use? N into x to the power n minus 1. That is 3 into x to the power 3 minus 1 plus d by dx of log x. D by dx of log x is 1 by x. So that will be simply result in 1 by x. So 3 into x to the power 3 minus 1 plus 1 by x. That is 3x square plus 1 by x. That is the differential of x cube plus log x. Okay. Have you seen that two examples? Now what you feel? Is it easy? If you know the general rules, then the differentiation is very, very easy. So remember, there is no such a question you differentiate these functions or some functions are given, you have to take the derivative of all. That will not ask. But that general rules we are used in physics derivations. So for practice only, for this is for means for understanding what is the method of differentiation or how you can take the derivative of a function. For that only I explained the method of differentiation and the general rules and examples. So anyhow, you have to remember that general rules. The method of differentiation is taking or measuring the variations in a function with respect to its own independent variable. That is very important, its own independent variable. And we have seen some general rules. That is not the only rules in differentiation. You can find many general rules in differentiation, but according to our use, all those are enough. So that is why we are restricting to those equations only, the rules only, and using those rules you can differentiate functions. So that's all about differentiation. What you feel now? Differentiation is easy. Differentiation is an easy method. I already told you, if you know that general rules and keep in your mind what you are going to do in differentiation, then that method is very, very easy. Okay, so this is one part of your calculus, differential calculus. And differentiation is a method in calculus during which or through which we are measuring the variation of a function with respect to the variation in its own independent variable. As the independent variable changes, that changes will affect the dependent variable also. And we are restricting the changes in independent variable very small, that is infinitesimally small, which means tending to 0. That is why we are expressing limit delta x tending to 0, delta y by delta x, that is expressed as dy by dx. Okay, dy by dx. So that dy by dx you can take derivative of y with respect to x. So we have an operator d by dx, d by dy, d by dz depending upon the different independent variables. And you can express the derivative of a function with respect to its own independent variable. Suppose you are having the same function of x you have seen, you are trying to differentiate with respect to y. So what will happen? D by dy of f of x. What you will get? 0, because differential of a constant is 0 with respect to y. As you are changing the value of y, f of x may change. No, because f of x will change only when the value of x changes. So with respect to y, f of x is a constant. Are you getting that idea? With respect to y, f of x is a constant. So, with respect to y, f of x cannot be differentiated. Keep in your mind, a function can be differentiated only with respect to its own independent variable. That is differentiation. Okay, that's all for today. You just go through the method of differentiation and try to solve some more examples in the next coming class. After differentiate, after defining integration also, I will give you some homework. Okay, so go through the method and make it thorough. We will meet in the next class. Okay, bye.